Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the variation of pressure with depth when fluid is compressible, which means that the density of fluid is variable. So let us take an example of air. So we know that air is not an ideal fluid, and air is compressible, and due to its own pressure the air gets compressed and the atmospheric pressure decreases as we go above the earth's surface away from the earth. So this can be explained by a simple fact that as you can see that the air column is this, and we know that due to gravity the pressure increases in the direction of gravity. So as we will move in the downward direction towards the gravity of earth, pressure will increase. So at surface of earth the pressure is P naught, which is 1 10 to the power 5 pascals, we know that. So at surface of earth P naught is 1.015 into 10 raised to power 5 pascals, and above, as we will go above the earth's surface away from the earth, the pressure will decrease. So let us first of all assume that density on the surface of earth is rho naught, density of air is rho naught, and obviously we are assuming that the temperature of the air remains constant. So PV is nRT, and PV is n is m by m RT. So P is equal to m by v into RT by m. So m by v is density, so P is equal to rho RT by m. This is the relation of pressure and density. P is equal to rho RT by m. And at surface of earth, we can say that P naught is equal to rho naught into RT by m. And if we assume this RT by m as some constant k, then k will be P naught by rho naught. Okay, so this is the first thing. Second thing, if we write down the value of pressure at the depth, so let us assume that we are going away from the earth's surface. So at a height of y from the earth's surface, the dp by dy will be equal to minus rho g, and this negative sign represents a fact that as we will move up from the earth's surface away from the earth, the pressure will decrease. So dp will be equal to minus rho g into dy, and integrating, the pressure limit will be from P naught to P, and the limit of y will be from 0 to h. So this P minus P naught will be equal to minus of rho g into, in fact, first of all what we'll do, we'll write this rho is variable. So what we have to do, we have to substitute the value of rho from this equation. So we know that P is equal to rho into K. So rho will be equal to P by K. So we have to substitute this value here. So dP will be equal to dP by dy will be equal to minus of